Primary resistor reduced voltage starters. In this presentation, we're going to look at how this reduced voltage starter system functions. Primary resistance, or sometimes also called reactance starters, can be used with any three-phase motor. They are the most basic operation out of all of the different reduced voltage starters. They are a closed transition type starter, and it reduces the line voltage across the motor during the start sequence. The primary resistor starter operation, at least the power circuit, looks like this. Of course, there would be three parallel sections for all three of the line conductors traveling to the three-phase motor. When we first start the motor, we have a voltage drop due to the current flowing through a large resistor. This voltage drop in turn causes a reduction in voltage across the motor, and with a reduced voltage across the motor causes lower current and lower starting torque. As the motor speed increases, eventually the control sequence will time when the run contact is to be closed. The starter will close the run contact on this starter, which causes the current to flow through the closed contact rather than the resistance due to Ohm's law. At this point, we have 0 volts across the resistance and the full 208 across the motor. In this way, it is a closed transition because at no point was the motor without voltage. An alternative to a primary resistor is a primary reactor where a large inductor is used. Same operation. This is an example of a primary resistor motor starter with a single stage voltage. Let's take a look at how the timer relay will then engage and how the system will function. The time delay relay is used to determine the length of starting time. And when we energize the full system, we can press the start push button down. It energizes both the S and the TR coils. S, of course, changes state for all of the different contacts that it is controlling, and the TR starts counting down. At this point, the motor is starting, and we have a voltage drop across resistance. The motor will pick up speed, and the time will be determined by what has been set on the time delay on energization relay. Once the countdown has been completed, the time contact reverts or changes state, and in this situation, the A coil is then energized, which then causes the contacts that are controlled by A coil to change state to closed, which then makes all of the motor current flow through the contact rather than the resistive bank. At this point, the motor is in full run condition and there is no further steps. There are many different types of primary resistance motor starters, and they are by far becoming limited in their applications because of the amount of watts of power wasted by the resistors in the form of heat. In this situation here, there would be 3 different voltage stages by using 2 different resistive units and combining depending if you have A1 closed or A1 and A2 closed or only A2 closed, we get a different step of voltage. This is what we could expect to see. Usually the starting resistors are very large, they're wire wound, and they're to accommodate the immense amount of heat that would be generated.